A SOC comes in Monday morning to 2,400 alerts from one SIEM rule. Half point to normal admin work. A quarter have missing fields. Nobody owns the rule. The runbook link is dead. By lunch, analysts are mass closing the queue, not because they are lazy, but because the rule has lost trust. That failure did not start Monday. It started when the rule skipped its life cycle. Good detection content is not just written, it is drafted, tested, deployed, monitored, tuned, and eventually retired. The SIEM detection rule lifecycle is the managed process for taking a detection idea from draft to live alert, then keeping it useful over time. In plain English, it is quality control for SIEM rules. A rule starts with a hypothesis like, this behavior may indicate suspicious account use. Then the team proves the needed logs exist, tests the rule against old data, runs it silently, promotes it with an owner and runbook, watches its performance, tunes it, and retires it when it no longer earns attention. In NIST-style terms, this supports the detect and respond functions. It makes detection repeatable, measurable, and accountable, instead of a pile of searches nobody wants to touch. Without a life cycle, SIEM content turns into junk drawer security. One analyst writes a clever rule during an incident. Another copies it into production. 6 months later, the log source changes, the field name shifts, and the rule either breaks silently or starts firing constantly. Nobody knows why it exists. Nobody knows what a true positive should look like. This is how rule sets rot. The SOC loses time on noise and misses value from good telemetry. New analysts inherit mystery alerts. Managers see alert volume, but not detection quality. A lifecycle fixes that by forcing every rule to have a reason, evidence, ownership, acceptance criteria, and a review date. Here is the step-by-step flow. Draft first. Write the detection hypothesis, the exact log source, required fields, expected true positive examples, and known benign cases. Next comes peer review. Another defender checks the logic, naming, mappings, assumptions, and response notes. Then test against historical data before the rule ever alerts live. Pull a known time window. Confirm the rule finds examples you expect and does not explode on normal activity. After that, use shadow mode, also called silent mode. The rule runs in production data, but does not page analysts. Review the would-have-fired results. Only then deploy. Production deployment needs an owner, severity, alert routing, runbook link, review cadence, and rollback plan. Picture a SOC building a rule for unusual privileged account activity after hours. In draft, the analyst states the hypothesis, lists the identity and authentication logs, and adds 2 expected true positive examples from past cases. Peer review catches a problem. One business unit runs approved overnight maintenance. That becomes a known benign condition. The team tests 30 days of history. The first version fires too often, so they tighten the logic around privileged groups and unmanaged locations. Then they run 7 days in shadow mode. The would-have-alerted list is reviewed each morning. After it looks stable, they deploy it at high severity, assign the identity detection owner, link the runbook, and schedule a monthly fire rate review. The lifecycle's strength is trust. Analysts trust alerts more when rules have test evidence, owners, and runbooks. Leaders trust the rule set more when performance is measured. Engineers trust changes more when there is peer review and rollback. It also finds dead content, rules tied to retired systems, missing log sources, or noisy assumptions. But this is not magic. A lifecycle does not make bad telemetry good. It does not replace analyst judgment. It does not prove every alert is malicious. It requires discipline, documentation, and time. If the team treats lifecycle steps as paperwork, quality drops. The value comes from using each gate to ask, would this alert help an analyst act? The lifecycle sits inside the wider defensive stack. Log sources feed the SIEM. Detection rules turn selected patterns into alerts. Case management captures analyst verdicts, false positive reasons, and response outcomes. That feedback goes back into tuning. UEBA can help when the rule depends on baselines, like unusual user behavior compared with normal peer activity. SOAR can help after deployment by attaching enrichment, opening tickets, or running approved response steps from the runbook. But the SIEM rule still needs lifecycle control. Automation should not hide weak logic. Enrichment should not excuse missing ownership. The The lifecycle is how the SOC keeps detection content aligned with real systems, real risk, and real analyst work. Start with a simple inventory. List your top 20 SIEM rules by alert volume and top 20 by severity. For each rule, capture owner, purpose, log source, severity, runbook, last reviewed date, fire rate, and false positive rate. If any field is blank, that rule needs lifecycle work. Then define stages: draft, peer review, historical test, shadow, production, tuning, retirement. Create a one-page checklist for promotion between stages. Learn the basics of your query language, log schemas, field normalization, incident review, and metrics. Do not try to fix the whole SIEM in a week. Pick noisy rules first. Pick high-risk rules second. Retire rules that no longer produce action, learning, or coverage. Recap in 3 beats. First, every SIEM detection rule needs a clear draft: hypothesis, log source, expected true positives, and known benign activity. Second, no rule should jump straight to live alerting. Use peer review, historical testing, and shadow mode before analysts get paged. Third, production is not the finish line. Deploy with an owner, severity, and runbook. Then monitor fire rate and false positive rate on a set cadence. If the rule stops earning its keep, tune it or retire it. That is how rule sets stay healthy. Subscribe for a new Security Tools Decoded episode daily, plus the daily ranked CVE brief on this channel.